identifying the main features of the trig function. Now, I did include a table of values here for you, and I did it the way when I was learning how to graph these functions by hand, I would think to myself, sine. What do I know about the sine of x? And I don't want to deal with square root of 3 over 2. I don't, because square root of 3 to me is just not a convenient number. So what I do is I start thinking about, well, I start thinking cosine of 60 or cosine of pi over 3 is a half. So if cosine of 60 is a half, then sine of 30 is a half, right? Sine of 30, now 30 degrees is pi over 6. I can graph a half on my y-axis. That's not hard to find. And I could count by pi over 6s on my x-axis. So that could work. So that's why I included this point right here. And I said if x is pi over 6, the sine of x is 1/2. And then I thought about my unit circle. And I thought, well, let's think about the sine for a minute. What's the sine of this point? What's the sine of this point? Sine, remember, on your unit circle is the second coordinate. So sine of 0 is 0. Sine of pi over 2 is 1. Do you see where I'm coming up with these values? Sine of pi is 0. Sine of 3 pi over 2 is -1. And I could add one more. I could say the sine of 2 pi, and that's going to be 0. Okay, but then I noticed this amplitude. And that says everything is going to be 5 times what the height would have been if there was no number out here. So I really have to multiply each of these values by 5. And so we're looking at 5 halves. We're looking at 0. We're looking at -5 halves, -5, -5 halves, and 0. And when I go to graph these points, I am really graphing the 0, 0. That's what I'm graphing. And I'm going to drag these points over and do that, okay? I'm going to graph pi over 6, 5 halves. I'm going to graph pi over 2, 5. So I'm going to go ahead and do that. I'm going to do 0, 0. I'm going to do pi over 2, 5, because pi over 2 is on my curve. Pi over 2, 5. I'm going to do pi 0. And this makes sense to what I know about the sine curve. Starts at 0, goes high, goes to 0, goes low. So 3 pi over 2 should be -5. I can move this out of the way. Something like this. And then 2 pi gets back to 0. Okay, there's my sine curve. Now I can add a few more points for accuracy. I can add this point pi over 6. What is pi over 6? Well, it's 1/6 of the way to pi. Well, where's that? Well, 3/6 of the way to pi would be this. So pi over 6 is right here. Pi over 6 is up from the horizontal, right? So the y value is 1/2 at pi over 6. What's this value? This, if this is pi, or 6 pi over 6, this has to be 5 pi over 6. And so 5 pi over 6, I want to go up to, did I say 1/2? I meant to say 5 halves. That something didn't look right about that. Now I see why. Okay, so then 5 pi over 6, which is going to be real close to pi, I go up to 5 halves again. Now 7 pi over 6 is the next one. I'm going to go down to -5 halves. And 11 pi over 6, I'm going to go down to -5 halves. So then I can just connect these. I can undo that one because I don't love it. That's why I do it little bit of pieces, because then if you make a mistake or mess up, that's too pointy. You can do it again. And there it is. All right, why did I graph that? I graphed that because I had to find the key features here. And to me, it's easier to see the key features on a graph than it is in an equation. But we're eventually going to work towards the equation. That's important, okay? So let's look at our amplitude. First of all, it's 5, without a doubt, because it's the absolute value of whatever this coefficient of sine is. The domain, all reals. Every real number is allowed. I've just shown you one period here of it. The range, it goes from -5 on the y-axis to 5. And you can show your range using that kind of notation. You also could show it this way. -5 is less than or equal to y is less than or equal to 5. Either way is acceptable for range. And finally, the period, that's where you do 2 pi over whatever numbers multiplying the x. There's a 1 multiplying the x, so the period here is just going to be 2 pi. And I don't think I can get out of this thing now. Let's see.